Okay, so this one, we just need to get this going up by a little bit. So we're just going to put it in series with two other resistors, so 3 things in series. I want to get this to go up a little bit more. Again, get it just sort of aligned with the geometry is a good hint. So a third, so a half probably. And then a bit higher. Now this time it's a bit higher than a half. It's actually 2/3 we want it as. So the way we do 2/3 is it has to come into the platform, and then we have 2 squares on top of it, or under it. Let's do it that way. Whoops, no. Okay, that's gone the wrong way around, hasn't it? Let's go like that. Okay, so if you note the pattern inside the fuel cell, so if the full height is 1, and these squares are half the size of that one, and obviously that's going to be 2/3, and those are going to be 1/3 each. And I think we can just put this one all the way up to the top now. So the reason for these levels is it just gets you doing all the different main combinations of 3 components that you might need to do. So a third by putting them all in series, a half by putting the 2 in series, 2/3 by having 1 with 2 in parallel kind of on top or underneath it, and then 1 just on its own.
Dear Professor Moravian, we have received the preliminary results of your blood tests. Cholesterol normal, blood sugar level normal, vitamin D within range. We will be conducting further tests.
Okay, so again, we've got 3 things here. We've got 2 platforms and a resistor. And we've just been through all the different combinations of sort of values or powers that you can get with 3 things. So this one needs to come down by some amount. How much? So probably sort of aligned with the bottom of that, which would be, I think, 2/3. So let's see. So we want this to go through this and then split out into 2 and let's just do that. To see what's going on, let's just rewire. Okay, so that's kind of in the right place. This one needs to go up rather than down. It's a bit of this. Let's rewire that again. So the thing to aim for here is that pattern in the fuel cell. So 1 big square with 2 little squares on top of it or underneath it. So this one down here is the big square. That's 2/3. This is 1/3. Through. This one, I think we want these to go up by a little bit so that we can get up here and get all the way along, and then we push them all the way up. So let's get them all going up just a little bit. basically we need to get them all going up a little bit just so we can get, so to get this one up a little bit is the key one. Right, then we need to get this one all the way up to get up here. And it looks like you need to get all of them up to get out of the top here, but actually this middle one you don't need to, because you can drop down here onto here and then climb all the way back up because there's a ladder here. So these ones can just be in parallel. Okay, there's one. Okay, so this is one where we've got two platforms. And the trouble is that if we attach just the platforms up to the fuel cell, let's just do it. You can see the problem. So we can get onto this platform, but the trouble is they stay the same distance apart, and we can never jump from one to the other. Go and see the hint anyway.
To be able to catch the platform on the left, you're going to need to slow it down. But you don't want to slow down the platform on the right. So you need to have a think about what the pattern of squares needs to look like inside the fuel cell. Yeah? You've got 3 machines in the room. One of them needs a big power square. That's the fast one. And one of them needs a very small power square. It's a slow one. So, what's that pattern going to look like?
Okay, so we want this platform on the left to go slowly. So what we'll do is wire that up in series with this resistor over here. Rewire this so it's a bit less awkward. And then this other one, so you can see the 2 squares on top of each other. The other one can go in parallel with both of those. And that makes it go faster. So here's an almost identical puzzle. We've got a switch down here. We can get onto this platform. We've got to make this one go slower than that one. So we can just try the same solution again. Difficulty is we can't get to that first platform now. So let's just go and have a look at the hint, shall we?
previous room, you made one platform move slower than the other by giving it a smaller power square. In this room, you have the added difficulty that the first platform is somewhat further away from the switch. Well, you still need to make one power square smaller than the other. It's just that you need to do it in a way that keeps all the power squares as small as they can be. With 3 machines, there's more than one way to make different sized power squares, you know.
Okay, so previous way, actually we can just see down at the bottom right here, we can see the pattern we made, one big power square with 2 smaller ones stacked up next to it. So the other way of making different sized power squares is with the sort of thirds, 2/3 pattern. So we go straight through the fast one, and then we split out into that one. Let's rewire that, and that one comes in here. So if you see the pattern now, again we've got one big one, 2 smaller ones, but they're all a bit smaller. So the big one isn't stretching from the very top to the very bottom. It's not a 1 by 1, it's a 2/3 by 2/3. And this should give us the slowdown that we need in order to be able to catch it. So of course you could have used this solution on the previous puzzle as well.
Dear Professor Moravian, a recent routine survey by one of our building inspectors, Johnny 3 School Lane, found serious structural problems with the building. You don't say. Most everywhere is brickwork. In addition, the ceiling of the cellar is a serious hazard and in danger of collapse. Well, I know that. I built it, didn't I? And therefore, no one must be allowed to walk along the path that leads around the back of the building until this is rectified. I'm not going to let anyone walk along that path. Haven't the council got anything better? In addition, our inspectors found serious breaches of the planning regulations, as the building appears to be considerably taller than the 4 stories for which you have permission. This strange-looking device measures the amount of charge flowing through it every second. Now this number is called the current, and it's measured in amps. Now the device is connected up to a door, and the door will only open if there's 1 amp of current flowing through the device. Now, if you look at the blobs moving through the wires, 1 amp means that 1 blob passes through it every second.
Okay, so a fairly long explanation, but actually there's only so many ways of wiring this up. So there's a resistor here. You can wire it up through this measuring device. And here we get this one blob. 1, 2, 3, 4. So we've got one blob passing through this every second. So that's 1 amp, which is shown here. Okay, well this time we've got 1/3 of an amp. Okay, actually let's look at the video.
Right, let's recap. Current is the amount of charge that flows through something every second. But another way to look at it is that it's the width of a power square. Now, this device doesn't have any resistance itself, so it doesn't actually have a power square, but it has a sort of power glowy line thing, which is like a power square that's been squashed flat. So this door will only open when there's 1/3 of an amp flowing through the device.
Okay, well, we can just put one device in. It goes up to 1 amp. 1, 2, 3. Let's see, get 2 in. It's half. Again, there's 1/3. And we can see that this must be 1/3 actually, because if you look in the fuel cell, you've got 3 squares on top of each other. The whole height is 1. So these must be 1/3 in height each. And because they're square, they must have 1/3 width as well. And it's the width that this is measuring, which is actually the width of that line there.